Awesome. So thank you for having me. My name's Arran Griffith. I'm the Fedora program manager. This is my first access in person. I think I presented once remotely, maybe last year, the year before. So I'm just really excited to be here. I work at, so Fedora has an organizational home at Lyricus, which is based in the States. However, I am Canadian, so I'm from New Brunswick. So it's kind of nice to be here at a Canadian conference. Typically, I'm joined by our Fedora program developer, Dan Field, but he's actually at Oxford today giving a presentation. Didn't make sense for us to exchange continents to give our talks, so I'm here. But I'm here to talk about a collaborative project that we undertook with one of our community partners from the University of Texas at Austin. And what we wanted to do was look at performance testing Fedora 6. In an infrastructure that involved, in their infrastructure that was for their data repository at Texas Advanced Computing Center. So it's a high performance computing center based out of UT Austin, and I'll explain a little bit more in a second here. Maybe. There we go. Yep. Okay. So just under a year ago, the Fedora community partners at TAC, they approached us and wanted to see if we would be interested in collaborating on a project with them to explore the limits of Fedora 6 and the capabilities of serving their needs in their high performance computing environment for a large scale data repository. Fedora itself is an open source repository system that is used in a wide variety of kind of academic and digital libraries of varying sizes. One of the nice things about Fedora is that it's super flexible. You can put anything you like into it, any file format, any size. But we don't have a large user base in research data repositories specifically. We tend to see academic libraries, digital collections, things like that in our community. So when they approached us and asked us if we'd be interested in looking at some performance metrics, obviously we were very interested. So the most current version of Fedora, which is Fedora 6.5 specifically, has been proving to us through hearing from community members and whatnot that it has resolved a lot of the performance issues that were being seen with past versions of Fedora, so Fedora 4, Fedora 5. But people still want to know what performance looks like, right? They want metrics. They want us to be able to explain, yes, it's performant, but performant to some people means different things, right? So your repository that has 1 million objects in it may be single small files, whereas somebody else may have less objects, but larger, deeply nested. So it was very challenging for us to, when people were asking about performance of 6, get up and say, yeah, it's performant. As far as we know, was always the follow-up to that, right? Because we didn't have specific concrete kind of metrics to point to. So we partnered with TAC to kind of look at making some benchmarks and being able to put some numbers on paper in their environment. So, we were able, they were super gracious, and TAC had a Fedora 5 instance that they were struggling with. They were obviously having performance issues. They wanted to understand if making the migration to 6 was going to be able to resolve the things that they were seeing before they obviously underwent all of that work. So specifically at Texas Advanced Computing Center, it's home to Design Safe, which is their NSF-funded data depot that contains natural hazards research materials and publications. And all of which is open access. So TAC provided us with the necessary infrastructure in order to establish a testbed environment to do the work in. So this included access to hardware, cloud storage, and infrastructure, and then obviously access to data sets that we were going to use from Design Safe. They were also gracious enough to partner with us, and we were liaising with stakeholders from their teams who are experts in cloud computing, data curation, and storage mechanisms. And then from the Fedora side of things, we provided Dan. So Dan is our sole program developer, and we had agreed as a community that this work was important. So we were going to allocate resources of Dan's time to actually executing the testing here. So initially, we defined some testing goals, and these revolved around establishing kind of the nuances in research data and for a research repository like Design Safe versus the more traditional kind of repository use cases that we're used to seeing. Research data in this case was natural hazards research data tended to have a lot larger file sizes as like a general statement, because we looked at some different data model or data setups, potentially many children, and they had different access needs. Potentially, the researchers might have been going in to curate data more regularly than, say, a digital collection that might be, you know, write once, read many. So here we wanted to kind of look at what that all would look like. And then we also wanted to identify the unique characteristic, those kind of unique characteristics, and see if there was anything that we could modify about Fedora specifically, if that's what was impacting performance. And one of the big things that we wanted to try to do was test to failure. So we wanted to throw a bunch of things into the system and try to hit those hard limits to understand what they were and where they were, where it was happening. Was it Fedora? Was it something else in the system that was causing the break? So yeah, we wanted to just kind of take as much data as we could and throw it into the system to see if we could hit those limits. And then from doing this, what we would be able to do is maybe optimize Fedora in some ways to accommodate this particular use case. And then we would also be able to provide recommendations to the community, both our community and potentially the research data community, on some best practices for this kind of highly specific use case if you were thinking of rolling this kind of infrastructure. The other things we were going to look at were different types of storage and configurations and how they would scale against the performance. And then we also wanted to provide a cost analysis to help users understand what the true costs of implementing something like this would be. And then, you know, we were able to use the HPC costs that TAC has, their costing model for using their systems, and compare it against, you know, other known cloud solutions, and provide a cost analysis on that. So just a few small things that we wanted to look at. But, you know, like I mentioned, we consulted with the TAC teams there and their specialists on best approaches to establishing a suitable testbed environment. And then Dan and the stakeholders were able to put that environment together. Maria Esiva, one of our colleagues from Texas Advanced, was critical in helping us select some data sets to test. And then the original idea was this testing to failure, but as soon as we kind of ran some initial performance tests, we kind of shifted, and we wanted to look at repetitive testing of ingest in order to, because we saw opportunities to improve in the ingest side of things right away. So we kind of shifted our focus there and started looking at improvements in ingest execution time. So one of the things that we did notice, though, when looking at the environment that we were working in, was that it's a shared HPC. So, you know, at different times of day when we were trying to ingest or trying to use the system, the load could be different based on what researchers were doing in the system. So we had to kind of test multiple times at different times of day to try to establish a benchmark that would make sense. And then so TAC has several systems, obviously, at their disposal, all of which serve different purposes. We were granted access to Cyclone. Oh, I used to have a picture. It's not there. Sorry. Well, it's a server stack, so it's as exciting as it can be. But we had access to Cyclone, which is an on-prem cloud storage infrastructure, or a cloud infrastructure system. It provided us a platform for cloud-native applications and workflows. It uses OpenStack to integrate disparate hardware into a flexible and diverse pool of resources that can be leveraged to deploy software systems at scale. This is a nice description of Cyclone. Some facts: it has 2,944 CPU cores, 8.3 terabytes of RAM, and 145.5 terabytes of backing storage. So it's big, but not their biggest. And then I mentioned our pilot partners selecting the data sets that we were going to use. These are two of them. Design safe data represents a wide variety of types of data, from natural hazards, engineering, and projects, like I mentioned. These within each of kind of projects, the file types can be anything from like LiDAR images to simplified things like PDFs and text files from you know, experimental tools, shake tables, things like that. So it can be, it's all kinds of things in all different sizes. So the first project that we looked at here was modeling and analysis of steel frame building systems. So it's many small files within a deeply nested hierarchical system. So this is a mixed collection of file sizes and file counts per directory. And testing this first project with the infrastructure involving Fedora 6 was enough to show proof of concept that Fedora 6 was resolving the ingest issues that TAC was seeing with their Fedora 5 implementation. So like round one, test one was showing us that there were improvements that could be made by moving to 6. So positive results right off the bat, which was nice. Project 2 was the M9 project ground motions. It was a little bit similar structure, but a little bit different. Once in Fedora 6, the OCFL representation made up, there was roughly 295,000 files and 201,000 directories, which took up about 1.5 terabytes of space. And we were able to optimize and ingest this in, I don't have the specific numbers, but we were able to ingest this in a time that for them was extremely reasonable versus what they were trying to get with Fedora 5. So really kind of happy with those initial results. I'm going to run through the results really quickly here. This isn't my area of expertise, so I just have some notes on it. But we initially tested using a single-threaded Python ingest client, which was set up to mirror what they had been using previously to ingest, and they were failing in Fedora 5. So to increase performance, we ran the same single-threaded tool through GNU Parallel, which saw large reductions in execution time. And then noting the performance benefits that we gained from this parallel processing approach, we took it to the next stage and built an ingest client, which utilized Python's native threading. And we were able to see even further gains in ingest improvements. So what we also noted is that OCFL is likely well suited to parallel ingest just because of the file structure and the way that OCFL is set up. And so there's no file locking, and we have to do a little bit more research here, but it does appear that this is the kind of best recommended approach for things of this size. And so the cost analysis was the other thing that we wanted to look at. So along with the actual time and performance information, we wanted to be able to put some dollars to what this might look like. So the comparison was against TAC costs for its data center users versus AWS. And I mean, the dollars are there on the screen. So a few things of note, though, TAC does not charge for data transfer, unlike AWS. This was not factored into the figures here. And we also didn't include any time for consultation of their stakeholders or Dan's time or things like that. So in order to provide kind of a true measure of what this might look like in terms of cost, this is just rough numbers, rough back of the napkin math, but there's kind of quite a large discrepancy there in what TAC can offer versus others. And then obviously, we only touched on a very small tip of a very large iceberg. We had very grand plans of what we wanted to do. We had written this project as a proposal for NSF grant funding, and unfortunately we're unsuccessful in doing that. So we've had to shelve a little bit of what we've been able to do because we have to reprioritize back to the Fedora community. Dan is, like I said, our only developer, so we can't put him all on this project for now. But performance testing is a community roadmap, a critical piece of our community roadmap at present. And so we are intending to pick up pieces of this and look at it as we're able to. But I think what we've seen initially has kind of solidified our response to Fedora 6 is doing what it's supposed to do. The users that have it are happy with the performance that they're seeing. And so our hope is to be able to put some more concrete, use those benchmarks that we've started to establish and build on them and grow with further testing over time. So if anybody is interested in getting involved in this work or following along with the work as we go, I would encourage you to find me. I can explain how to get involved in the Fedora community a little bit more. But obviously, we're super grateful for the team at TAC. They've continued to allow us to work in their infrastructure and use their hardware and their cloud setup to do the work. So we're extremely grateful for that. There's a whole bunch of resources here. The slides are in OSF, so you can get them. And there's my email address, Dan's email address. I'm around. You can come and find me if you have any questions. This is like my ideal situation. Oh my God. Stop. There's going to be a question. It's fine.
Did you ever manage to break it in your testing?
We did not. We did not break it. We have not even yet heard of a user who has broken an infrastructure involving Fedora 6. So we don't have any feedback from any community members at this point saying, you know, I tried to put this many files in it, or I tried to put this file structure into it and it broke. One of the things I will say is that Fedora 6 with OCFL as the preservation layer does have some data modeling recommendations that OCFL, the OCFL editors do generally recommend to support, so that you don't end up with what people are calling, or, you know, it's been, the term is out there, the OCFL bloating. But even with that kind of growth in the OCFL size, people are still finding that the performance is exactly what they were looking for. Again, that's our like generalized performance statement because we don't have the numbers to put on it. So it's doing what people want it and expect it to do.